Hello, welcome back. Today we're going to be talking about confidence intervals. We're going to learn how to use confidence intervals to predict the true population parameter. And we're going to start with finding confidence intervals for a population mean when the population standard deviation is known. And to do that, we're going to learn about critical value, standard error, margin of error. Okay. Now, the reason why we do confidence intervals most of the time is because of the inadequacies or inaccuracies of using point estimates. Take for instance x bar, which is the sample mean, which is the point estimator of the population mean. Okay, so x bar is the estimator of mean, which is the population mean. Now let's say for instance that we compute the sample mean and we get a value of 20, and the true population mean is equal to 21. So you can see that the two values are not the same. The statistic, which is the sample mean, and the parameter, which is population mean in this case, are different. Okay. Now, if we use interval instead of this point estimation, the sample mean is what we call the point estimator of the population mean. Now, if we use interval instead to do this, if we have here, this is 20. Let's say that this is where our sample mean is, and then we'll have right here 21. This is our mean. Okay, and you can see that the sample mean and the population mean are in different positions. However, if we use an interval, let's say 18 to 22, well, this is ugly, but I've got to manage it. So if we use an interval, say 18 to 22, you can now see that the population mean, the true population mean is captured, is within the intervals. So when we use confidence intervals, we are increasing our chance of including the true population mean. And this doesn't happen when we use a point estimation. Okay. So the use of confidence intervals increases the chances of our including the true parameter in the interval. Okay, so that is why we do that. We use confidence intervals to predict the population mean or population parameter. So to do confidence intervals, we will have to, like we talked about, we want to know the critical value, the standard error, the margin of error. Now this is the formula for the confidence interval, where x bar is the sample mean, the z alpha over 2 is the critical value, standard deviation, population standard deviation, that's sigma, divided by square root of n is what we call standard error. So when you multiply the critical value and the standard error, you get margin of error. So our margin of error, let's call it ME, is equal to the critical value, let's call it CV, times the standard error, SE. Okay, so when we multiply critical value by SE, or critical value and SE, standard error, we get margin of error. Therefore, the confidence interval is going to be x bar plus or minus the margin of error, ME. Okay, so if you look at the table to the left here, the definitions are made. Another way to write the confidence interval is this way, where you have the population mean in the middle. So the population mean is falls between this lower boundary and this upper boundary. Okay, so this is how another way to represent that, the lower boundary on the left and the upper boundary to the right. Okay. On the table below, we can see that we have defined what each term means. X bar is the sample mean, Z alpha over 2 is the critical value, sigma is the population standard deviation, N is the sample size. Then you have sigma, which is the population standard deviation divided by the square root of N as our standard error. Then the margin of error is the critical value times the standard error. You can see it up here, critical value times standard error gives you the margin of error. Okay. So the first thing we're going to do is to learn how to find the critical value using TI-84 plus. Okay, so we'll find the critical value, then we'll find the standard error, multiply both to get the margin of error, and then we'll get the confidence interval. So we want to find the critical value for a confidence level of 80%. Now, when you have a confidence level of 80%, that tells me that the alpha is 20%. Okay, this is 0.8, which means alpha is 0.2. Now, to find the critical value, you can very simply do this using TI-84 plus here. I am going to go to second vars. I'm going to go to envnorm, which is number 3. That's how we find the critical value. So the area, I'm going to do 1 minus alpha. Remember, we said that alpha is 20%, which is 0.2. So I'm going to do alpha 1 minus alpha, which is 0.2 divided by 2. Okay, that's on the area. You can see 1 minus alpha over 2. That is what I did. And that's what you're going to do all the time. 1 minus alpha over 2. Actually, that should be 0.9. Okay, because if you do alpha, that's 20%, 0.2 divided by 2, that's 0.1, and subtract it from 1, that's 0.90. Okay, so you can put 0.90 here, or you just can do this. So the mean is 0 and the standard deviation is 1, so we can paste and enter. So we have a critical value of 1.281. Okay, now if you go down here, we made explanations. If you want to do this by hand, to calculate critical value for 80%, first you convert that to decimal, then find alpha, which is 0.2, then that's 1 minus 0.8, that's 0.2. Therefore, alpha over 2 is 0.1. Then subtract 0.1 from 1, that gives you 0.9, and that's what we did. So the simple way to do this in the calculator is just to do 1 minus alpha over 2. Okay, so this is what we just did. Okay, this is another way. This is put in a table to show you how that was done. We have alpha 0.2, alpha over 2 is 0.1, 1 minus alpha over 2 is 0.9. So in the calculator, this is what we just did. Went to second vars and typed in 1 minus alpha over 2, or you can just type in 0.9. Mean is 0 and the standard deviation is 1. And the answer we got was 1.281. That is our critical value. Okay, now we're going to take this critical value and go to find the confidence interval. And of course, one last thing we need to find is the standard error. Okay, so look here, the mean, look at this example. A sample of 64 students where students' height has a mean of 6.2, the standard deviation is 1.2. Want to construct confidence intervals for the population mean with the following levels. So first, the confidence level here is 80%, and you can see we already found the critical value. Okay, so the sample mean is 6.2, the critical value we already found up here, 1.281. Then we have the population standard deviation is 1.2, n is 64. So standard error, remember, is sigma divided by square root of n. So it's going to be 1.2, which is sigma, divided by square root of 64, which is 8. And when you do that, you get 0.15. So that's our standard error. So now, to get the margin of error, we multiply the standard error by the critical value. And that's what we did here. Okay, so and what do you get? 0.192. So that's your margin of error. Now remember, the confidence interval has a lower boundary and upper boundary. To get the lower boundary, just subtract the mean, the sample mean, which is 6.2, subtract the margin of error from 6.2, okay, which is the sample mean. So this is what we did here, the lower boundary, okay, and we'll get 6.008. Then to get the upper boundary, you add the same margin of error to the sample mean and you get 6.392. So our confidence level interval is 6.008, which is the lower boundary, comma 6.392. Okay. So how do we do this using the TI-84 plus? So we're going to go to tests. We're going to go to start, and we're going to go to tests, and we're going to choose Z interval. That's number 7. Number 7. Okay. Now we're going to use start. If you are using data, it means that you already entered your data in the table. Okay, L1, L2. But here we have the statistics, or the data we need, or the statistics. So what we have here is the mean is the standard deviation of the population is given as 1.2, 1.2. The mean of the sample is 6.2, N is 64, and the confidence level is 80.80. So now we are going to calculate. So you can see that when we calculate, you can see the confidence interval 6.0078, which is what we have, the lower boundary 6.008, and then the upper boundary is 6.3922. You can see 6.392. Okay, so that is how we can easily get the confidence interval using our TI-84 plus. Okay, all you need to do is to go to start, you go to statistics, and go to tests, and you go to number 7. Okay, number 7, if you entered your data, there's a table, then you go to data. But if you know the population standard deviation, you know the sample mean, and you know the sample size, and of course the confidence level, you always go with statistics or stats. Okay, so you enter these values, it's going to give you an output, the lower boundary and the upper boundary, and that will be your confidence interval. Okay, so we have learned how to find the critical value using TI-84 plus. We can easily compute the standard error by hand, and we can just find the confidence interval using this method, or we can simply go to TI-84 plus to find that. Okay, so next time we're going to see how we can find the confidence interval when the population standard deviation is unknown. Thank you. Bye bye.